Yeah, bloody hell's it, man. Alright, we need to determine the value or values of x for which this expression has real values or a real value. So the mechanics behind this is quite complicated, so let's walk through it quickly. Okay, to get real numbers, I need to square root a positive number, and that will give me a real number. Additionally, if I square root 0, it gives me 0, and that's also a real number. And it really helps to see the other side of the coin here. If I square root a negative number, it's going to give me something that's non-real. And anything divided by 0 is undefined, which is also not in the realm of real numbers. So we've got to watch out for these two things. So if I start looking here and I analyze the top, we've got to know a very important rule in algebra. And that important rule is that anything squared will always be positive, or it could possibly be 0 if x was 0. 0 squared is just 0. So that means this x squared here will always be positive or 0, and then I add 4 to it, so it eliminates the chance of it equaling 0. So the top will always be positive. And that means only the bottom of the fraction could possibly make this thing positive or negative. So if I want real values, I'm going to want a positive number divided by a positive number, so that underneath the square root I get something positive. So what I do is I grab the bottom, 9 minus x, and to make it positive, I want it to be bigger than 0. If I say something is bigger than 0, that's a fancy way of saying it's positive. Just a small side note here, I cannot make it equal to 0, because then I'm going to get divided by 0 and I'm going to get the undefined stuff. Now, after I've done that, I just solve for x. So I'm going to take this minus x over to this side, and then press the mundo. Here's our answer. X should be smaller than 9. Remember, this crocodile always eats the bigger one. So we're currently reading it from right to left, which is like Arabic. So if you want to swap the order to read it better, please, by all means, do it. And if you do swap the order, just make sure the croc is eating the same oak as before. And now we can read it from right to left, so x is smaller than 9. And your 1 mark purely just comes from the answer over here. Right, moving on to 1.1.2. They ask where it is not defined. Right, that's a fancy way of saying where is it undefined. And we briefly went over that in the previous question. So anything divided by 0 is undefined. So to apply that logic to this question, the top can really be anything. I don't care about the top. I care about the bottom. I want the bottom to be 0. So I grab the bottom, I make it equal 0, just like that, and then I solve for x. So I take this minus x over to the other side and we get x equals 9. Just like that, and you just get 1 mark for this answer. And there is a sneaky little way you can check this with your calculator. So I've typed this expression into my calculator, but instead of x's I leave open little brackets like this. And I'm going to fill this 9 into those open brackets. And anything that's undefined will give you math error on the calculator. So I'm expecting to get math error here. Yes, a math error, and so we know it's undefined now. Math error could also come about from non-real stuff. Okay, in 1.1.3, given that x is 1, is the expression rational or irrational? Validate your answer with an appropriate calculation. Okay, so I'm going to gooi this one straight into this expression. Let's sub it in quickly. Okay, so you can just see I've changed these two x's to a 1. I like to put them in brackets so that I can more clearly see what I changed x to. Okay, and ain't nobody got time for that, bro. That's going straight in the calculator. Okay, so we just pop it in as we see it there, press equals, and I get this root 10 over 4. And that root 10 over 4 is kind of talking to me. So if I have a root in my answer, then it's definitely going to be irrational. If this simplified to like 2 over 3 and there were no roots, then it would definitely be rational. So the root is my trigger to recognize that this thing is irrational. So I've just got to answer their question and say therefore irrational. For those of you brave souls out of there, I could have worked this out manually. So I could have said 1 squared is 1, plus 4 will give me 5, and 9 minus 1 will give me 8. And then the square root will still sit over that 5 over 8. And now the same logic is present. There's still a square root in my answer. These are not perfect squares, so I can't really simplify that further. So it still leads to the conclusion of irrational. But why do all that hard work when your calculator can sort it out for you in a fraction of the time? Right, so let's see where the 1 mark comes from. Literally just comes from the word irrational. Alright, on to the next question. Next question asks, determine a value of x for which the expression will yield a recurring decimal value. So recurring means repeating, and decimal value, let me show you what a recurring decimal value is. So it's something like this, 1.6666, and then that goes on forever. Could even be 2 repeating numbers, 2,23. Okay, now if we need to find a value of x, it's just a fancy game of trial and error. I'm going to start putting in values and seeing which one will give me it. So let's bust our calculator out. Okay, so the easiest value to start with is a crispy little kanda, my bro, a little 0. So I normally do like 0, 1, minus 1, 2, minus 2. So let's start off with 0. Alright, S to D, look at that, a recurring decimal. So if I make x 0, I'm going to get a recurring decimal. Your calculator just automatically rounds it off because it's got limited memory. But essentially this is 0.66666, and that 6 carries on forever. And we just need to show what x value we used to get our recurring decimal, and you simply just get 1 mark for the answer. In question 1.2, we're going to jump into the quadratic equations. Okay, we've been given this equation, and we need to determine x if k equals 5. So we're going to chuck this 5 into k's place here. Okay, so as discussed, we just change this k to a 5 as they instructed us to do. And now I can see an x squared, so it's definitely a quadratic equation. It's already in standard form. Everything's on one side and it equals 0. So I can actually factorize straight away. So we're going to start factorizing. And I look at the number in front of x squared, it's a 2. And I'm going to write the factors of 2 underneath each other here. Luckily it's a prime number, so it's only got 2 factors, 1 and 2. And then I'm going to look at the factors of 5 and write them underneath each other over here. And then I'll go across the court like I'm serving in tennis. When I go across the court, I multiply. So 2 times 1 will give me 2. And then I'm going to go across this way. 1 times 5 will give me 5. And now I somehow need to add or subtract these two numbers to get this minus 3 in the middle. And I think I can get that accomplished by saying plus 2 minus 5. Okay, so plus 2 minus 5 is definitely working to get me that minus 3. Now I transpose these signs back in over there. And after I do that, I chuck a little x here, chuck a little x here. And then those form my 2 brackets. So it doesn't matter what order you write them in. I'm going to write this one first, and I don't have to write this 1 over here. So I'm just going to say x plus 1 for my first bracket. And my second bracket will be 2x minus 5. And now that our quadratic equation is factorized and equals 0, I'm going to hit the banana split, my bro. So I separate factor 1 and factor 2 and make each one equals 0 separately, just like this. So I'll make my first factor, factor 1, equals 0, or I'll make my second factor, factor 2, equals 0, and then I'll start working with them separately. If you're curious to know why we do that, it's because 0 times anything equals 0. So if I make this bracket or factor 0, I don't care what this bracket is, it can be anything at once. I'm still going to get 0, and it will maintain the integrity of the equation. It will make the equation true. Okay, now I'm going to solve for x separately. So I'm going to take this plus 1 over and it becomes minus 1. In this one, I start by taking the minus 5 over and it becomes plus 5. And then I divide both sides of the equation by 2 to get rid of this 2 over here. And then these 2's cancel with one another. And we get our second answer for x to be 5 over 2. And then we've just got to separate the solutions with the word or. Yes, it's got a hard fought 2 marks. Okay, first mark comes from the factors over here. Second mark comes from the correct 2 answers. In question 1.2.2, they told us to solve the same equation if k equals 4. And they gave you a massive clue over here. Correct 2 decimal places. The alarm bells are ringing, but for the quadratic formula. So if you see this, I want you to link it to this in your brain. You form a cognitive association, bruh. Okay, so let's start off by putting this k value into k's place over there. And after we've done that, before we use the quadratic formula, it needs to be in standard form. So I'm going to analyze, is this in standard form? It's in the right order, x squared first, x in the middle, and the number at the end. And it does equal 0, so it is in standard form. So we're going to go straight ahead into the quadratic formula. Bear in mind this is on your formula sheet, so you do not need to know it off by heart. And then we just need to quickly recognize our a, b, and c values. A is the number in front of x squared. B is the number in front of x, and make sure to take the sign as well. And c is the number without an x, and make sure to take the sign here too. Alright, now that that's done, let's start putting it into this crispy little formula. So I'm going to hit a x equals first of all. And then it's going to be minus b. So it's going to be minus, and then I'll put b in this bracket, so a minus 3 goes in there. And then I chair the plus minus there. And then the first thing that goes under the root is b squared. Just make sure to use brackets. Okay, and then I've got a minus 4, and then I'm going to put a in this bracket over here. And lastly, I've got to put a c in this bracket over here. My c is negative 4. And then that sorts out the top. Now we're going to do a huge divide line, and we're going to put 2a at the bottom. And now we finished with substitution. Now we go to our calculator. Okay, then we're going to type it in our calculator with the plus first. We're going to ignore this minus. So let me just take 6 years to type this in quickly. Yes, it's feel like an old man after that. So you can see I've just done the plus one first. Okay, then I'll slap a equals there, and it gives me this. They want it correct to 2 decimal places, so I'm just going to have to S to D here, and then my 2 decimal places are going to be 2,35. And then do not retype the whole thing in your calculator. Just press the right button, up or right, keep going right, and change this plus to a minus, and then press equals and S to D, and there's our second answer, minus 0.85. Yeah, now we're finished. Okay, let's have a look where the 3 marks come from. So 1 mark for the correct substitution, and then 1 mark per pop for each answer. Question 1.3, we have a classic surd equation. A surd is a root, so it can be a square root, it can be a cube root. In our case, we've just got a stock standard square root. Okay, and what we want to do is make sure the square root is by itself. And it can have a minus in front or a number multiplied by it in front. But as long as you have one term with a root in it, you are safe to go to the next step of squaring both sides. So we just square both sides separately. Now don't fall in the trap over here. Do not shower the power. If you see a square on the outside of a binomial, that square gives you instructions to write the bracket twice. And the reason why we do that is so we can set ourselves up for foiling. If you're comfortable enough, you can foil straight away. And I'm going to do you one better. I'm going to write this bracket twice to show you how it simplifies. Okay, so if I write this bracket twice, then a minus times a minus is a positive. And if I have a square root multiplied by another square root, and they have the same thing underneath, then the square root just disappears. So from this whole ordeal, we just left with x minus 2. Another good way to see it is like this. So a minus times a minus is a plus. So that's why the minuses have disappeared. And then I multiply what's underneath the square roots. So I multiply those. So I get that bracket squared, and then this square cancels with this third to give us what we previously had, x minus 2. Okay, now over here I'm going to FOIL. And when I FOIL, I multiply. So f stands for the first term in each bracket. X times x is x squared. O stands for the outer two terms, so it's x and negative 4. So x times negative 4 is negative 4x. R stands for the inner two terms, so negative 4 times x, once again, is negative 4x. And L stands for the last two terms in each bracket, so negative 4 times negative 4 is plus 16. Okay, and while I'm here, I'm just going to do these two like terms. Minus 4x is minus 8x. And now I'm going to analyze what type of equation I have. The highest power of x I see is x squared. So this is a quadratic equation. So I want to get standard form. And to do that, I'm going to have to move these two terms over to the other side. And at the same time, I want to get the right order. So I want the x squared to be first here. The minus 8x can stay where he is. Now when I move this x over, it's going to become minus x, because over here it's plus x. When I move it over the equal sign, it becomes the negative version of itself. So let's put that minus x over there. The plus 16 can stay next to this. And I'm going to move the minus 2 all the way at the end here next to the 16. And when I move it over the equal sign, it becomes plus 2. It becomes the opposite sign of what it previously used to be. And if I take everything over, then there's nothing left here. There's kinda, my bro, 0. Okay, so what I was talking about the order, I want the x squareds first. I want everything with the x in the middle. And I want the things without an x at the end, aka the numbers that do not have a variable. Now we're going to do the like terms. Over here, if there's no number, we assume it's a 1. And minus 8x minus 1x is minus 9x. If you're having a little bit of trouble with those mental calculations, just use your calculator to triple check. Just type it in without the x's. So minus 8 minus 1 will give you minus 9, and then you just glue the x onto that. Okay, and then plus 16 plus 2 is plus 18. Okay, now we can have, well, we have standard form, it equals 0. So now we can start the process of factorizing. So I look at this number here, the factors of 18. When I do the tennis court method like I did previously over here, you only do the tennis court method when there's a number in front of x squared. These ones are a lot easier. If you don't have a number in front of x squared, or if it's 1, then you can just have a look at the factors of 18. And we need to use those factors to get negative 9. So 1 times 18, that won't work to get me negative 9. 2 times 9, close, but it still won't work. 3 times 6, perhaps that will work. After I've identified the correct factors, I need to add or subtract them to get negative 9. And I can do that by saying minus 3 minus 6. And once I've done that, I'm going to set up 2 empty brackets with the x at the beginning. And inside of my first bracket, it's going to be x minus 3. Inside of my second bracket, it's going to be x minus 6. And then one last thing you must do if you are using this method, just check if you multiply these two numbers that it does give you positive 18. Negative times a negative gives me a positive. 3 times 6 gives me 18. Okay, so it's working on all fronts. So now we hit the pisang split, where we make each factor equal 0 separately. Take this negative 3 over and it becomes positive 3. And we take this negative 6 over and it becomes positive 6. Okay, and here are our two answers for x. Now we're not quite done. We need to test the answers. Anytime you see a square root in the equation, you must test your answers. So we're going to put each answer in and see if it works. So if I put this 3 into x's place here, on the left hand side I'll get 3 minus 4, which is negative 1. And then I'm going to put this 3 into x's place over here. Yes, ain't nobody got time for that, bro. That's going straight in the calculator. Okay, so I just pop that in, press equals, and you can see it gives me negative 1. Which means that x equals 3 is definitely a solution. That guy is working. And now we're going to test the 6. Okay, so if I put this 6 in x over here, I get 6 minus 4, which gives me 2. And then I'm going to put the 6 into x over there. Yo, I don't have time for that. So I'm just going to use this one from last time. Change this 3 to a 6. And I get minus 2. So because I'm getting different things on the left hand side of the equal sign and the right hand side of the equal sign, it tells me that this is not an answer. So we've got to put a stroke through this equal sign. And why that happens is when we square both sides, we normally create a solution that's not supposed to be there. So at the end, we've got to triple check ourselves and get rid of it, and that is worth a mark, so you have to do it. Okay, and then quickly having a look where these 6 billion marks come from. Squaring both sides to get this gets you your first mark. Standard form gets you your second mark. The correct factors get you your third mark. The critical values for x gets you your fourth mark, and the rejection of the invalid answer gets you the fifth mark. In question 1.3.2, we have the quadratic inequality. Yo, but how do you know that, bro? Okay, quadratic, the highest power of x is x squared, and this symbol here is called an inequality. Not a crocodile mouth, an inequality. And the first step with quadratic inequalities is getting everything to one side and making it equal 0. So I'm going to take this 3x over, and additionally I'm going to take this 2 over. And I also want the correct order. So I want the x squared first, and then I'm going to move the 3x over here next to it, and it's going to become minus 3x when I take it over. Okay, then I'm going to slap the plus 4 next to that. And then we're going to chisenyonke this 2 over, and he becomes negative 2. And then the crocodile mouth, or the inequality, must still point the same way. And then I've got nothing left here, so it's a crispy little kanda, my bro, 0. Once that's out the way, we're going to dollar these like terms quickly. Plus 4 minus 2 just gives me plus 2. Okay, once standard form is out the way, we're going to factorize a trinomial. And thank goodness, this is an easy one because there's no number here, aka there's a 1 there. So I'm going to look at the factors of 2. 2 is a beautiful little thing. It's a prime number. So 1 times 2 are the only factors. Okay, now I've got to think to myself, how does 1 and 2 add or subtract to get negative 3? And it looks like we have to minus both of them. So we say minus 1, minus 2. And now my two brackets that I'm going to factorize is going to be x minus 1 as well as x minus 2. Okay, now I'm going to get my critical values. Now if you don't put CVs in this line, you will get marked down. These are not the answers, they are just stepping stones to get the answers. Okay, and how we get the CVs is we take factor 1 and make it equal to 0. And then we yoink this minus 1 over and it becomes plus 1. Then likewise for factor 2, I grab it, make it equal to 0. I dollar this minus 2 over and it becomes plus 2. And now I have my two critical values, 1 and 2. Now we're gonna hit a young sketch here. We're gonna draw the parabola. Okay, so it's going to be a stock standard happy face because the number in front of x squared is positive, aka it's a 1. And then with our critical values, the lower one goes on the left and the higher one goes on the right. And once we've done that sketch, we're going to analyze this inequality. It's asking you, where is this parabola above 0? AKA, where does this parabola have a y value that's bigger than 0? So this is the y-axis here. So I want to find out where this parabola is above the x-axis so that it gives me a positive y value. Okay, so we are inching our way closer. Okay, so this parabola has negative y values in between 1 and 2. And there's actually 2 places on the parabola where it's got positive y values, over here and over here. So we've got to actually have 2 separate answers. We've got to list them separately. So the first answer is whenever x is smaller than 1, I'm going to get these positive y values. And I write it just like this: whenever x is smaller than 1. And then I'm going to set myself up to write the other one. So I'll put the word or, and then it's this region over here. So it's from 2 till infinity. So it's from 2 onwards. So it's whenever x is bigger than 2. And we list it just like this: whenever x is bigger than 2. And yeah, we are done. Okay, let's have a look where these 4 marks come from. So first mark comes from standard form, boss. Okay, second mark comes from your factors. And then you get a marker pop for each answer. And then just before I go, the answers can also be written like this. I can say x is an element from minus infinity all the way to 1, or x is an element that starts at 2 and goes on to infinity. So it's like saying from minus infinity all the way to 1, and then from 2 all the way to infinity. And to shorten up that notation, you can do this. You just separate the 2 brackets with the word or, and there is a symbol for or in maths. It looks like a capital U without a tail. So yeah, it can also be written like that. Next up, we have to solve simultaneously for x and y. So we're going to start with the easier equation. This one looks more complicated because of these squares on x and y. So we're going to start with this equation. Now I can either choose x or y. I'm going to make quite an informed decision based on the numbers in front. This one has a 2 in front, which makes life more complicated. This one does not have a number in front, aka it's a 1. So I'm going to choose to work with y. So I want to get y on its own. So we're going to choose in yonke this 2 over to that side. Just remember, when you do that, plus 2 becomes minus 2. Now that we've got y on its own, we're going to make the necessary substitution. So this over here, we're going to put it into all the y's we see over here. So luckily there's only one y, so I'm going to sub this in to y's place. So what I do to make my life easier is I rewrite this, but instead of y, I leave an open set of brackets. And inside this bracket, I clap this thing in there. Okay, now don't fall in the trap. This square is giving you instructions to write the bracket twice, my bro. Okay, after we write the bracket twice, we are going to FOIL the brackets. And after we FOIL, we must still keep it in a bracket because of this minus over here. So let's go ahead and FOIL quickly. Okay, so when we FOIL, we multiply the first 2 terms. 2x times 2x gives me 4x squared. Okay, the outer 2 terms, 2x times minus 2 gives me minus 4x. And then the inner 2 terms, minus 2 times 2x, that gives us another minus 4x. And then the last 2 terms, minus 2 times minus 2 gives me plus 4. Yes, that's a lot of 4's, bro. Okay, while I'm here, let's quickly do these like terms. Minus 4x gives me minus 8x. Okay, after we dollar the like terms, we're going to distribute this negative into the bracket. And then a nifty little shortcut: if you distribute in a minus in a bracket, the signs inside the bracket just change. So this was positive 4x, now it's going to be minus 4x. Minus 4x squared, sorry. Okay, a minus times a minus is a plus, so we're going to get plus 8x. And a minus times a positive is a negative, so we get minus 4 at the end there. Okay, once that's done, we want to get standard form. So we want to get all of these terms over to that side, and we want the correct order. So I'm going to move the x squared first, and he's going to become positive 4x squared. And then while we're here, let's quickly do these like terms. 2x squared plus 4x squared is 6x squared. Okay, now I'm going to target the x's. I've located one here, move it over, it becomes minus 8x. And then I'm going to move the 2 and the minus 4 over quickly. And don't forget the equals kinda at the end here, bro. Okay, minus 2 plus 4 is positive 2. So I'm going to simplify the like terms to plus 2 there. Alright, now, I'm not quite at standard form just yet. I can see all of these are even numbers, so all of them are divisible by 2. And that's exactly what I'm going to do. I'm going to divide them all by 2, and then finally, we've reached standard form. Okay, 6 divided by 2 is 3, and then I slap the x squared on there. Minus 8 divided by 2 gives me that minus 4. 2 divided by 2 is 1. 0 divided by anything is 0. Sure, this question goes on, hey? Right, now we're going to factorize this guy. And this is quite a difficult trinomial to factorize because the number in front of x squared is not 1. So we've got to set up a tennis court. Luckily 3 is a prime number, so I'm going to put 1 and 3 underneath each other. And then I have to use the factors of this guy, this 1 at the end. So luckily 1 only has 2 factors, 1 and 1. So I'll put those underneath over here. And then I'll go across the court like I'm serving in pickleball, and I'll multiply. 3 times 1 just gives me 3. And then I'll go across the court down here and multiply. 1 times 1 just gives me 1. And now I've got to ask myself, how do I add or subtract these to get this number in the middle, minus 4x? Looks like we're going to have to hit the old minus 3, minus 1 gives me minus 4. And then last thing, I clap a little x here, clap a little x here, put these signs back in, and then I've got my 2 brackets. Okay, so the first bracket will just be x minus 1. I don't have to write this 1. And the second bracket will be 3x minus 1. Okay, after we get the brackets, you know the drill by now, bro. Factor 1 and factor 2. I make them both equal 0 separately. So I make factor 1 equal 0 or factor 2 equal 0. Okay, on this side, I'm going to grab this minus 1, take him over, and he becomes plus 1. So we get x equals 1. And then with factor 2, I'm going to take this minus 1, take it over, it becomes plus 1. 0 plus 1 is just 1. And then I divide both sides by 3 to get rid of this 3 over here. And then these 3's cancel with each other, and it just leaves me with x equals a third. And now the x values are done. But we still have to get the y values. Don't forget the y values, bro. Right, so I'm going to do them on the side here. Yes, this is taking up like 16 pages, bro. And the best equation to come back to is this one. So I'm going to grab this equation. I'm just going to write the y equals in front. And it's going to take on this order now. Y equals 2x minus 2. 2x minus 2 equals y. They're the exact same thing. So I'm going to replace this x with my first answer for x. So I'm going to replace it with a 1. And then 2 times 1 is 2. 2 minus 2 is 0. Don't take chances. Triple check yourself. It is kinda indeed, my bro. And then I'm going to grab this equation again. Y equals 2x minus 2. And I'm going to replace this x with my second answer for x of a third. So let's go ahead and replace them quick. Okay, and then ain't nobody got time for that, bro. Slap that straight in the calculator, dollar the equals, and we get minus 4 over 3. And after 6 long years, we are finally finished with this question. And let's have a look where these 17,000 marks come from. The first mark comes from getting y by itself, aka making y the subject of the formula. The second mark comes from substituting that into this equation. Third mark comes from the crispy standard form over here. Fourth mark comes from the correct factors that we got through the tennis court method. The fifth mark comes from our x values, both correct x values, and the sixth mark comes from the correct y values. Question 1.5 asks us for which values of p will basically give us unequal roots for this formula. So we've got to find the values of p that will give us unequal roots. So let's have a look at our nature of roots formulas. So the nature of roots formula is b squared minus 4ac. A, b, and c are representative of the coefficients of x squared, x, and no x respectively. So if I want real roots, I model it to be bigger than or equal to 0. If I want real and unequal roots, I model it to just be bigger than 0. And if I want real and equal roots, I make the discriminant equal 0. And if I want non-real roots, I make my discriminant less than 0. We are going to be heading down this path, the unequal roots. The question specified they want unequal roots. So let's get rid of the other equations. Okay, but we have a bit of a problem. We need standard form so that we can get A, B, and C. So I'm going to grab this equation quickly. And to get this in standard form, I'm going to move the P over next to the 3 here, and it's going to become plus P. And that's officially all it takes to get it in standard form. Now the coefficient of x squared is my A value. And the coefficient of x forms my b value. And everything that does not have an x forms my c value. Now that we've got standard form out the way, we're going to chuck a, b, and c into this formula, and then we're going to see where it takes us. We're going to strap on for the ride, my bro. So b is 4, so I'm going to change this b to 4. And then a is negative 2, so I'm going to change this a to negative 2. And c is this mess over here, so I'm going to change c to this, but don't forget brackets, it must be inside a bracket. Once our substitution has been made, we are going to solve for p. So 4 squared is 16. Minus 4 times minus 2 will give me plus 8. And I'm going to leave the rest of it for now. Now I'm going to distribute this plus 8 into the bracket. Alright, plus 8 times negative 3. A positive times a minus is a minus. 8 times 3 is 24. And 8 times p will just give me plus 8p. And nothing will change with the rest of the inequality. This will still point in the same direction, and we've still got our crispy little kanda over there, bro. Right, let's start simplifying this. 16 minus 24, triple check with your calculator. It's going to be negative 8. And then we're going to shine this negative 8 over to that side. Just remember, you change the sign when you do that. So if you're going over the inequality symbol, it's going to change sign to positive 8. Now I need to get rid of this 8 in front of p, so I divide both sides by 8 to get rid of it. Okay, and then these 8s over here are gonna grab it, bruh, they cancel with one another, leaving you with just a p on this side, and 8 divided by 8 is simply just 1. So whenever p is bigger than 1, we're going to get unequal roots for this quadratic formula, or unequal x-intercepts if you want to see it that way. So let's have a look where the 4 marks come from. We get 1 mark for the substitution into the discriminant formula, 1 mark for the condition of making the discriminant bigger than 0. 3rd mark comes from the correct delta expression, and the 4th mark comes from the correct final answer. Okay, welcome to your challenge round. So for which values of p will this equation have roots that are both positive? To start this off, I'm going to divide everything by negative 1 so that I get a positive p here. It's much easier to work with positive p rather than negative p. And in summary, what that does is it changes the signs of everything. So this minus 2x squared became positive 2x squared. The plus 4x became minus 4x, etc., etc. Now, to help you understand this question, I'm going to draw this parabola. because the number in front of x squared is positive, it's going to be a happy face. And then I'm going to show you around this parabola a little bit. This plus 3 will represent the y-intercept of the parabola. And because I have a negative b value, I know that the turning point of the parabola sits on this side of the y-axis. So it's to the right of the y-axis. And then from the previous question, we discovered if p is bigger than 1, we are going to get unequal roots. So how you should picture this is p is a horizontal line. And if I place that horizontal line anywhere above 1, I'm going to get unequal roots. So it stands to reason if I place it on 1, I'll get equal roots. So the parabola won't actually look like this. Its bum is going to sit here. Its turning point will sit on this line. So it will look more so like this. So anytime p is bigger than 1, so let me show you. If I draw the horizontal line here, then the roots are unequal. I get unequal x values for the roots. And the roots are representative of where this horizontal line touches this parabola. And that happens all the time when p is bigger than 1. So if I put the horizontal line back down here on the turning point, then what I can do is draw that horizontal line anywhere in between 1 and 3, and it's going to give me positive roots. And just to illustrate that a little bit better, let's say p was 2. And I'll draw it there, then we can see that these x values are positive x values, which means I'm going to get positive roots. If I had to put the vertical line up here past 3, then what's going to happen is one of my roots will actually give me a negative x value, and the other root will give me a positive x value. So I can't put p above 3. That will be true no matter how far I move the horizontal line upwards. So in summary, I want p to be anywhere in between 3 and 1. And I'll state that like this. P must be smaller than 3, but at the same time bigger than 1. Yes, this question was some other type of nasty stuff, my bro. And then to quickly have a look at your 2 marks, any valid method gets you your 2 marks here. You've got wiggle room to be a bit creative with the solution. And then in question 1.6, we need to show that this monstrous equation has no real roots for p and q, is an element of real numbers, and q cannot equal 0. So let's walk through how we're going to do this. So we are going to have to sub a, b, and c into the nature of roots formula. But there's a problem. This thing is not in standard form quite yet. So that's going to be mission number 1, is to get this equation into standard form. So let's go ahead and do that. So after I've grabbed the equation, I'm going to move both of these terms over to that side of the equal sign so that everything equals 0. And remember, we want the right order. We want x squared first. We want the one with x in the middle. And the one that does not have an x, we want it at the end. Okay, so this is going to stay in front. When I move this over, it changes from a minus to a plus. And then we're going to move this okie over all the way to the end here. And he's a minus over here, so if I move him over the equal sign, he's going to become plus q squared. And as always, we have the equals kinda at the end, my bro. Yeah, now I can extract my a, b, and c values. The coefficient of x squared is a, so p squared plus 1 is my a value. And the coefficient of x is my b value, so 2pq is my b value. And lastly, everything that does not have an x is my c value. And once that's out the way, we're going to sub those guys into the discriminant formula. Now, when you sub into the discriminant formula, there should be no x's there. So we do not take the x squared or the x. They disappear when we go into the step. Right, so I'm going to replace b with 2pq inside a set of brackets. And then I have the minus 4, minus 4. I'm going to replace a with p squared plus 1 inside a set of brackets. Just remember, brackets bless your life, my bro. And then one last thing needs to be substituted. We need the c value at the end here. So I'm going to replace the c with q squared, and for comfort's sake, I'm going to use brackets, my bro. Okay, now we're going to start to simplify this guy. So I'm going to shower the power in here. 2 squared is 4. Shower it to the p and I get p squared. Shower it to the q and I get q squared. So it's 4 p squared q squared. And just for interest's sake, I could have written the bracket twice as well. That works. 2 times 2 will give me that 4. P times p will give me that p squared. And q times q, you guessed it, gives me q squared, boss. Okay, and then over here, I'm just going to distribute one thing at a time. So let's get that q squared inside there. Okay, and then q squared times p squared is just p squared q squared. And q squared times 1 is just plus q squared. Now that that's done, I'm going to distribute this negative 4 into that bracket, and then I've officially got rid of all the brackets. Okay, so if I take the minus 4 and distribute it to this first term, minus 4 times p squared q squared is just minus 4 p squared q squared. You just like glue it on. Same thing is apparent here. Minus 4 times q squared is just minus 4q squared. Alright, I'm seeing some like terms here, bro. Same variables, same exponents. And 4 minus 4 gives us the classic kanda, my bro. So if we simplify this thing, these two terms, 4p squared q squared minus 4p squared q squared, we're gonna slap them out of here, my bro. Slap. Okay. So we just left with minus 4q squared as our discriminant. And now we're going to analyze our discriminant and jump to our conclusion. So that important algebra rule is coming back into the picture. And that rule dictates that anything squared is always positive, or it could possibly be 0. So this q squared over here will always be positive. And then also they said q can't be 0. So this will never ever be 0. It will only be positive. Now I'm taking that positive number and I'm multiplying it by negative 4. And a negative times a positive will give me a negative number. So my discriminant will always be negative. Okay, now let's see how we're going to write that up. Firstly, we've got to say q squared will always be greater than 0. And I do not put the equals to sign here because they told us it cannot equal 0. So if I multiply both of these sides by by negative 4, I'm going to get a negative. So negative 4 times q squared will always be smaller than 0, aka negative. So that successfully proves that my discriminant, which is represented by a triangle, is less than 0. So we can conclude that we have non-real roots. If we square rooting a negative number, we get non-real roots. Okay, let's have a look where the 16,000 marks come from in this painful question. Ranch, we had 1 mark for your standard form there, boss. 1 mark for your substitution, 1 mark for the simplification of your discriminant, 1 mark for the correct expression for your discriminant of minus 4q squared, and then the last mark comes from your explanation behind non-real roots. You are not going to get a mark for this conclusion because they told you that. So you get a mark for explaining how your discriminant is negative.